Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to all of you or not. Students, I'm waiting for your answers in the chat box. Am I clearly visible and audible to all of you or not? So today we are going to start with some basic concepts of chemistry and starting with the very first important thing, that is law of chemical combinations, right? So today we are going to discuss some numericals based on law of chemical combinations, what is the definition of that, and with the help of example we will understand what exactly is that thing, right? Now, if you see the sequence of past few years, it is not very directly asked, right? But I would still suggest you to do this particular topic, right, from your first chapter. Reason being, because you never know that these kind of topics, they sometimes relate with other topics of chemistry, and that's how they can ask you this question, right? So that's why knowledge of chemical combination is very important for you. More important is not the definition but the application of laws, right? That means how to solve the numericals. So today we are going to focus more on the numericals and question practice and less on just the theory part, right? Theory part, you are not in 9th or 10th class and they will ask you the definition of this thing. They will ask you the application form of that thing, right? Okay. So are you all ready for this, everybody? Hi, Abhijit, Tarun, Mathun, Vignesh. Yes, Indresh, Viti, Zoya, Shravya, hello, hello, hello. Maruti, hi. Very, very good evening, students. Very, very good evening to everyone here. So, completed this. Very good, very good. Very good, Abhijit. That's excellent. That's excellent. Okay. So, now let us start with the laws of chemical combination. But before that, let me just tell you one thing here. Because right now, you are in that state where you're actually right now preparing for JEE 2027, right? Then students, this is a very important information for all of you, that we are conducting IVSAT scholarship program, right? This is also for droppers as well, repeated batch as well. If you're preparing for JEE 2027, all you have to do is register yourself to this and you can avail up to 90% scholarship here. For the dropper students, if you are just here to complete your backlogs, then students, we are providing in the batch guaranteed rank improvement as well. And you can visit our center here in Bangalore also, JP Nagar. This is our address, this is our number. Our counselors and teachers are there to meet you, to counsel you regarding your preparation and guiding you throughout. And if you're from some other state, right, then you can go through this. Like this is our full where our Vedantu centers are located. You can locate the nearest location and you can visit the center just by saying that, ma'am, I'm from Vedantu JEE English. I'm a Vedantu JEE English student and I want this counseling. So face to face, you can get the guidance that you need for the upcoming 2 years, right? So guys, a link is in the description, right? You can go and check that out. That will really, really helpful for you, right? Because it's not beneficial of doing mistakes again and then regretting, right? Better is you take advice from the experts, right? So all you just have to say that I am a student of Diksha Ma'am from Vedantu JEE English. I'm a student of Shreyas sir from Vedantu JEE English. I'm a student of Namrata Ma'am from Vedantu JEE English. That's it, right? And your problem will be solved, right? Okay. Yes. Very good. Ramya is in 10th class. Okay. And how many are you from 9th and 10th class and how many are you in 11th class? I want to know that in the chat box. Let me know my cuties, right? Let me see how many of you are in 9th class, 10th class. If you're in 9th and 10th class, you are at this point so serious about your studies, then firstly, I'm clapping for you here. Hats off to you. You will definitely crack. Reason being, very, very rare students are that much serious, right, about their preparation of 11th and 12th and JEE, right? If you are one of them, then surely your JEE advanced seat is waiting for you. Yes, right, because it's very rare quality that I have seen in students. Let me see. Ma'am, I'm Gaurav, I'm in class 12. So I think that the students who are in class 12, they are here to complete their backlogs. right? And the students who are in class below than class 10th, I can see 7th as well here, right? Interesting to know that, right? Then these students are basically preparing themselves for what is coming here, right? And the class 11 students, we are here for you, right? You are like at the point where you need this lecture, you can't delay beyond that, right? Okay, yes. Class 12, class 11, class 7th, class 11th. What else? What else? Can I see? Can I see the chat read speeding it fast? Class 11th, been following your classes since 3 and 4 years. Okay, thank you so much, Rishwan. That means a lot to me. I think you must be following my classes of 9th and 10th as well, isn't it? Okay. So, Dharan. Okay. So, let us start this without wasting any more time. Let us start this, right? I was studying and they showed on my recommendation, just came to meet up, ma'am. Okay, Kodati, no issues, no issues, right? That's great that some students are here for their refreshment as well. Great, 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 great. Okay, so have you hit the like button or not? Because when you hit that smash button, when you hit that like button, what happens is the same students, right? You know how YouTube works, right? YouTube works in that format. If I am someone who is always looking for chemistry videos, good chemistry videos, right? And there is some other student also who is looking for good chemistry videos. If I am watching some video, right, I like that video, that means YouTube thinks that, okay, Diksha likes this video, right? That means Diksha is recommending this video to everyone out there who has the same feed, right? So same kind of content will be recommended to your mates also. They will also be they will also get help, right? And moreover, this will benefit me as well, right? I will also get appreciation that all the hard work that we do for you is actually benefiting you. It is just like a motivation dose for us, not a drop for us, right? Okay, chal. Okay, now let us start. Too much talk we have done, right? Now, students, first is we have laws of chemical combinations, right? We are studying about chemistry. So we need to understand that what are the laws in chemistry that are obeying these when this reactant is getting converted to product, what is exactly the laws that it is obeying, right? So we have these five major laws, that is law of conservation of mass, law of constant proportion, law of multiple proportion, Gay-Lussac's law of gaseous volume, Avogadro's law, and the last one is a surprise law for you. I'll tell you that, right? Very rare teachers will teach you this law, right? This is a surprise law that I'll tell you then. This is not in your NCRT. It is not written in your NCRT, but it is equally important for you when you're studying all these laws, right? Okay. So, first we will talk about these five laws here. First law is law of conservation of mass. This you have studied even in lower classes. In 9th, 10th, you have studied about this conservation of mass. That means we are saying that whenever there is some reaction occurring, the mass of the reactant is equal to the mass of the product. This is what we want to say when we are saying that there is conservation of the mass, right? So, in the physical and chemical change, any change is occurring there, mass can neither be created nor be destroyed. It can only change from one state to the another state, right? It can only change its arrangement. That means the mass of reactants will be equals to the mass of the product. This is what we want to say by law of conservation of mass. But this is one exception here, that is the nuclear reactions, right? So you must have heard about nuclear reactions, like what we say, like now India was in the war zone, right? What everyone was talking about. Everyone was talking about nuclear war. What if this happens? You must have heard about this term nuclear war in the news channels, right? What is this nuclear war, right? So nuclear weapons are made, right? Every country has that nuclear weapon, like most of the countries, right? And if in a war zone they have to use that, it is like disaster, not only for the other country but for themselves as well, right? Because throughout the generations, it will like the generations will be spoiled, like the generational, not only about we are talking about the deaths, we are also talking about the generational genes will be fluctuated there, DNA will be fluctuated, right? So many things will happen, so many births that will take place after years, they will be handicapped, right? So why this is going to be that, right? Why they will be disabled, right? Because this nuclear reaction, these atomic bombs, right? What they do is, from the mass, right? We have some reactants. They produce such high amount of energy in the atmosphere, right? That high amount of energy is disastrous, right? So it's a proper study. Nuclear reaction is a different study. I'm just telling you a little tint of it, that this is very, very disastrous, right? Now, why this is so disastrous? Because very high amount of energy is released here, right? Now, if you see that you have mass, which is getting converted into a very high amount of energy, right? That means mass is not getting conserved here. Mass is getting converted to energy. And how many of you, I know you're like, ma'am, is this physics class? This is not physics class, but my point is not to cram, not to have students who are just cramming things here, right? Let's discuss this. E is equals to mc square. You must have heard about this particular formula so many times in your life, right? If you're a science enthusiast, right? So E is equals to mc square. This is a formula given by, this is equation given by Einstein, right? Now, according to this equation, mass can be converted to energy, energy can be converted to mass. The example is the nuclear reactions, where a lot of amount of mass is converted to a lot of amount of energy, right? That means mass is not conserved in the nuclear reactions. Okay, mass is not at all conserved in the nuclear reactions. This is the exception that we have for law of conservation of mass. Now, from your NCRT, this is a snip that is very important for you. Let's go through this. This law was put forth by Lavoisier in 1989. Year you don't have to see, just remember Lavoisier. He performed careful experiment studies. Combustion reaction leads to conclusion that all physical and chemical changes, there is no net change in mass. Hence, he reached to conclusion that matter can neither be created nor be destroyed. This is called law of conservation of mass. That's it, what you have to do. But the exception is nuclear reactions, and there are other exceptions as well, right? That is beyond your study, right? Now, definition is very simple. Now, let's talk about some, to understand things, we need to also go through the questions, right? So, first question is 1.7 gram of silver nitrate. So, silver is Ag, nitrate is NO3 negative. So, this will form AgNO3, right? Now, they are saying that 1.7 gram of silver nitrate dissolved in 100 grams of water is taken. So, this is 1.7 dissolved in 100 gram of water. Water is 100 gram, right? Was taken this much of sodium chloride dissolved in this. Now they are saying that sodium chloride you have, and it is also dissolved in water, that is 100 grams. How much sodium chloride? They are saying 0.585 gram. Okay, is added to it, and chemical reaction occurs, right? 1 point this much of silver chloride, okay, silver chloride is formed. Now they are saying that this much of silver chloride and this much of sodium nitrate is formed. So now what is said to us that what you have, this much of silver nitrate dissolved in water is taken, this much of sodium chloride dissolved in this much, in which in one beaker you have this thing, in other beaker you have this thing. Once you add both of these things, then what will be formed? Once you add both of these things, you have the formation of sodium nitrate, that is NaNO3, and you have the formation of sodium nitrate and silver chloride, that is AgCl, right? This much of sodium nitrate is formed. Justify the data, obey the law of conservation. So this NaNO3 is given to be how much? This NaNO3 is given to be silver chloride is formed as 1.435 gram. This NaNO3 is given to be 0.85 gram. Right? This is the whole data that is given to us. Now, can you see this is the reactant side, that is the product side, right? All we have to do is we add up the reactant side, that will become equal to the product side, and that is going to be your answer here, right? Okay, so what we will do, total mass before the chemical change will be equals to mass of AgNO3, mass of NaCl plus mass of water, right? Because water was also there. What all we have here is AgNO3, water, NaCl, H2, right? So we'll add all the masses here, 1.7, this plus 200. Now, why you added 200 here? Because this was 100, this was 100, this together makes 200. You will add all of this. Now, in the answer side, what you have is, we have mass of AgCl, mass of NaNO3, and mass of water, right? You will say, ma'am, how water appeared all of a sudden, right? How water appeared? Because water is there, no? In the product side also there will be water, right? Because this is a solution of water, this is a solution of NaCl in water, right? So water will be there in the beaker, right? So that you have to add only 0.85 plus 1.435 plus 200 of water that was there before also, that will be there after also, and after adding up what you will see, the answer is going to be same, that is the same answer you have. That means law of the law of conservation of mass is applicable here. It is applied here, right? Okay. Ma'am, how to know the reaction? This is reaction is given in the question, right? All you have to do, you just have to watch my basic foundation lecture where I have taught you about the ions, okay? If you know that Ag positive is there, NO3 negative is there, you cross multiply it, you will get the formula, right? And what is happening? This Ag is combining with this Cl, this Na is combining with this NaNO3, and that's how you have the product side, right? Okay. But for that, you need to know the valencies of the ion that I have taught you in the basic foundation lecture. So that's why I taught that lecture before taking the actual, before starting the actual chapter, right? Okay. Now, the second law is law of definite proportion. See, in the starting, you will feel like, ma'am, it's so easy, ma'am, right? Okay. But in the end, as we will move toward the sixth law, things will get little tricky. So you have to have 100% concentration, 100% focus here. Okay. Yes. Okay, Naga, the thing is that when a teacher is teaching on the board, no, if the teacher is just telling you one statement and then suddenly the teacher is just looking at the comments, what happens? There is a break in the speech, right? So that's why I always tell my students that you type your doubts in the comment section, right? Once I complete that particular thing, I'll surely look for your doubts in the chat box, right? Okay. I'm checking Vedantu online prime batch. Okay. Okay. Awesome, Bhavesh. Awesome. I'm from Telangana. Yes, Naga. How many lectures will the chapter go, ma'am? I think 4-5 lectures. Yes, 4-5 lectures. Right. From the next class, we are going to start with the mole concept. Okay. Yes. So let's see this law of definite proportion. Now, what do you mean by definite? Right? What do you mean by definite? Definite means fixed proportion. Right? Definite means fixed. We'll say, na, definitely I'll do that. Surely I'll do that. Why? Definitely fixed. Right? That is a constant thing. That means law of constant proportion. We are saying that, simple words, tell me one thing. This is the formula of which thing? This is the formula of which thing? Water, right? Now, I am drinking this water. What do you think? What is the formula of this water that I am drinking? What is the formula of this water that I am drinking? Right? I have taken my water from RO. So is this a different formula? Right? Someone is not drinking RO water, right? Someone is drinking normal water. Someone is drinking water from the ocean. Someone is drinking water from the lake, right? So someone is drinking water from a different city, different state, right? So are these formulas of water different, right? No, right? The impurities can be different, right? The impurities added, the minerals can be different, but the formula of water will be same. That is H2O throughout the world, right? A very poor person is also drinking the formula H2O, right? A very rich person, right? They are also drinking the formula H2O, right? Now, no matter there are so many other waters right now in the market, right? This and that water that is advertised by these big industries, right? But water is water, that is H2, right? Now this is what I am saying right now, that is called the law of fixed or law of definite proportion. That means if I am picking out water, a compound from anywhere in this world, that compound will have a fixed formula. That compound will, water now will always have two hydrogens and one oxygen. Always and always it is going to be this formula. If I am saying this is a different compound that is called peroxide, H2O2, right? So that's why it is absolutely not possible for a compound to have different formulas, right? If you talk about NaCl, now salt will always have this formula, that is NaCl only. If you talk about carbon dioxide will always have this formula only. And based on this law only, our chemistry is based, that every single compound is having a fixed formula, fixed number of atoms in a definite proportion. Ma'am, what do you mean by proportion? Proportion means, let's say I am taking an example of water, that is H2, right? Now proportion is in two cases, okay? Fixed, two type of proportions are fixed here, right? So I'll just draw that what two types of proportions are fixed here. If I talk about water, the number of atoms, in case of number of atoms, and the second one is the mass, and the second one is mass of atoms, the ratio of mass of atoms. So if I talk about the number of atoms of hydrogen and oxygen here, this is hydrogen, this is oxygen. If I talk about the mass of atom, this is hydrogen, this is oxygen. Can you tell me what is the answer here? See, if I talk about the number of atoms here, hydrogen is 2 atoms, oxygen is 1 atom, so it is going to be 2:1. So always water is going to be in the ratio of hydrogen ratio, oxygen is going to be, number of atom ratio is going to be 2:1 here, always and always this is going to be true. Now if I talk about the mass of the atoms, this is one hydrogen has atomic mass 1, that I have also taught you in the basic foundation lectures, right? Okay, one hydrogen has 1 mass, right? So 2 hydrogen means 2 into 1 is 2, right? So that will be 2 ratio. Now oxygen is having how much mass? Let me see in the chat box, right? Yes, very good. 2:16. That is, if you divide it with 2, that will become 1:8. So this is the ratio by mass. Whenever we call this 1:8, this is by mass. 2:1 is the ratio by atoms, right? If they have mentioned 1:8, that means they are talking about ratio by mass. Okay. Now coming to Abhijit's question here, right? Abhijit is asking that, ma'am, impurities will not affect the formula. See, impurities are different, right? And the formula is different. Formula, the molecule, we are talking, it's not like molecule of water is like this. Okay. So impurities are lying here, impurities are lying. So impurities are not breaking the bond of oxygen and hydrogen or water, right? That molecule is remaining the same only, right? And we are talking about the formula of that molecule of the water, right? Okay, understood? Yes. Now let's talk about the next thing, that is law of, this is from your NCERT, right? You can see the same definition here. Compound always contains exactly the same proportion of elements by weight. Always and always they will contain same proportion by weight. Now there was a natural sample of copper, right? Synthetic sample. and they were containing the same percentage of copper, same percentage of carbon, same percentage of oxygen here, right? Okay, he concluded that irrespective of the source, a given compound always contains same elements combined together in the same proportion by mass. Because the number of atoms are same, that's why the mass is same, right? Now, those, if you ask me, ma'am, if I replace hydrogen by deuterium, right, mass will change. So, the ratio by mass will change. So, that will not be water, that will be heavy water. So, H2 and D2 are two different things, right? So, even if you replace any atom by its isotope, that is not going to remain the same thing. That will be entirely different thing, right? Okay. Yes, everybody. Clear, no? So now let's talk about some question based on this. Question is, copper oxide was prepared by three different methods, right? By three different methods we are preparing copper oxide, right? In case 1.75, that is in first case, I'll just write it here, right? Three cases are given to us, right? Three cases are given to us. In the first case, 1.75 gram of metal gave this much of oxide. 1.75 copper will give you how much oxide? 2.19 gram of oxide. Oxide. Okay, oxygen I am writing here. How to write oxide? So I'll write it like this. Oxide. Okay. Then in the second case, 1.14 gram of copper is going to gave 1.43 gram of oxide, right? Third one is the third case, 1.45 gram of copper will give you, when strongly heated in a current of air, yielded 1.83 gram of oxide. Wait a minute, oxide. Right? Now tell me one thing, you have copper oxide. First you need to tell me the formula of copper oxide. Copper oxide. Oxide is 2 negative, copper is 2 positive. 2 positive and negative will cancel, answer will be CO. So I'm going to replace this oxide with CO, right? So I'm just directly going to write it here, CuO, 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 and this is also your Cu. Now, what they are asking is, show the given data illustrate the law of constant proportion. That means we have to see whether they are giving you the same formula or not, right? The same thing they are giving or not. For that, what we have to see, we have to make one thing constant here, that is the amount of copper I can make constant. Okay, amount of copper you can make 100 gram, 200 gram, anything you can make. I am going to make it 100 gram. Okay, so just to ease the calculations, we are making it 100 grams. Okay, so you'll see in 100 gram of copper give how much oxide in each of the following. Understood why we are checking for 100 gram of copper, right? Because we need to make one thing constant here. So firstly, what I'll make, let's say this is Cu, this is Cu, this is oxygen. So if I make copper as constant, that means 100 gram of copper I have. If the same amount of oxide is given in each of the cases by 100 gram, same amount of oxide is given, that means it is actually following the law of definite proportion, right? So let's see that here. Let's see that. Okay. So directly what you will do, will solve it for 100 gram of copper oxide is formed by how much copper, right? Okay. Or you can also say that how much of copper oxide is obtained by 100 gram of copper. That's totally your choice how you want to proceed this, right? So in the first case, what we have is 2.19 gram of copper oxide contain 1.75 gram of copper, right? Now you must know how to apply unitary method that I am going to teach you here, right? So 2.19 gram of copper gave you 1.75 gram of, wait a minute, this was copper oxide, right? Copper oxide gave you this much of copper. So I am saying 1 gram of this will give you 1.75 divided by 2.19, and 100 gram will give you multiplied by 100. So always, what is the formula that we are getting, right? I'm just giving you this formula directly. Let's say you have x gram of copper oxide is giving you y gram of copper, because we have the relation of copper and copper oxide, right? So I need to fix one thing. I am fixing, let's say I am fixing the copper oxide, right? Okay, so I am fixing that. So 1 gram of copper oxide will give you y by x of copper, and 100 gram will give you y by x of multiplied by 100. This much amount of copper. Now, if it is giving the same amount of copper, then the answer will be correct, right? Okay, so answer will be this formula. You need to apply y by x into 100, right? So I'll apply this here. This is your y by x. What was y? Y, we have taken copper, right? Y is copper. This is x. This is y. This is x. This is y, and this is x. So here it is going to be y by x 1.75 divided by 2.19 multiplied by 100. This is going to be 1.14 divided by 1.43 multiplied by 100, right? And what about this one here, right? Y by x 1.45 divided by 1.83 multiplied by 100 here. And by doing this, you will get your answer, right? Everybody clear on this part? How to apply, right? The future, I am sorry, yaar, I forgot to saw your comment, right? When I saw your text here, I was like, oh my god, I again forgot to saw your comment. Life is too busy, yaar. What to do? But don't worry, one day I'll definitely saw your comment. Today I'll definitely see. I'll also reply to your comment. Okay. Yes. Today in this video you comment down. Now I have actually forgotten that which video you were talking about where I have to see your query. Right now you commented down in this video, then I'll check it out. Okay. Yes. So that is clear to everybody. So this answer you will see is the same answer you are getting everywhere. So that means it is actually following the law of definite proportion, right? That means we are clear on that thing. Next question is, everybody let us see the next question here, right? Okay, right? Okay, yes everyone. 1.08 gram of copper wire was allowed to react with nitric acid, right? Copper wire you had that was allowed to react with nitric acid. This is the formula of nitric acid. Ma'am, who will tell us the formula of nitric acid? These things should be on your tips, right? Once you go through full syllabus of chemistry, this will actually be a very simple thing for you, right? So this is nitric acid. The resulting solution was dried and ignited when this much of copper oxide was obtained. Okay. They are saying that because you know what? This is a very good oxidizing agent. This is a very good oxidizing agent. Ma'am, what are oxidizing agents? Oxidizing agents are those agents which are going to oxidize something, right? Like teachers are going to teach, right? Teachers are going to teach, right? So similar way, oxidizing agents are going to oxidize, right? So they are going to oxidize means they are going to add oxygen into this copper, and the resulting will be your copper oxide was obtained. In another experiment, this much of copper oxide was heated in presence of hydrogen yielding and this much of copper, yielding this much of copper. Show that the above data is in accordance with law of constant proportion. Okay, so two experiments are given to you, right? In two experiments, what they are saying is this much of copper was allowed to react with the nitric acid. The resulting solution was dried and ignited when this much of copper oxide was obtained, right? Here you have the formation of copper oxide. This much of copper oxide was obtained here, right? In another experiment, you have copper oxide was heated, resulting this much of copper, right? Same thing you have to do. The relation is with copper and copper oxide. So what you have to do, you have to see that if you take a constant amount of copper oxide, are they both in both the experiment? Because what you have is two experiments, okay? You have two experiments. One experiment is here you are getting CO. Second experiment is in which you are having copper oxide and it is being heated giving you copper, right? Now your main focus point should be this is copper and this is copper oxide. This is copper oxide and this is copper. That should be your main point. Now, in these kind of questions, just like we did in the last experiment, what we did, we fixed one amount of copper oxide. If let's say I'm fixing it for 100 grams, this 100 grams should give X amount of copper and this 100 gram also should give that same X amount of copper. If it is giving you Y amount, no, this will be 100 grams here, okay, 100 grams. And if it is also giving you the same X gram of copper, then you can say that it is definitely following the law of definite proportion. Is that clear to everybody or not? Is that clear to everybody or not? What we are going to see, what we are going to do in this question, right? Okay, what we are going to do in this question. Everybody, the point of the why, or I always teach it like this. Firstly, I'll always conclude the numerical like this only. Firstly, you have to go through the question. Then you have to understand. This is the way, because right now you are in the initial stage of understanding the numericals of physical chemistry. So how you're going to proceed towards the numericals, right? First, you have to see what is the question. Then write down whatever is given to you, right? Don't jump into solving the question, right? First, you write down whatever is given to you. Then see that what they have asked you. Then try to correlate this thing that what I can do here, right? Okay, now we will answer this very easily because we know that we have two experiments. This is the first experiment, the second experiment. So what we are going to do here, in the first experiment, copper is getting converted into copper oxide because this, ma'am, do I have to do this? No, right? Why? Because you should know only one thing, that nitric acid is a very strong oxidizing agent, right? So that's why it is going to oxidize copper to copper oxide, right? These variables are given to you. This is 1.08, this is 1.35. Now, just like in the last question, here I will fix it as 100 grams. I have to find it in 100 gram of CO, how much amount of copper they are going to give me, right? So in 100 gram of CO, it will contain how much? Same thing. Same thing. Ma'am, how to apply unitary method? See, simple thing is, let me just draw it here. Let me just write it here. That was copper to copper oxide, right? If I write that, you have how much copper oxide? 1.35 gram of copper oxide is going to give you how much gram of copper? 1.08, right? Then 1 gram is going to be 1.08 divided by 1.35. Then 100 gram is going to give you multiplied by 100. Isn't it the same thing, right? Okay. So apply the unitary method, right? In physical chemistry, unitary method application should be on your tips, right? If still you're not able to understand unitary method, then do let me know in the chat box, because that is a very, very important thing for physical chemistry. Unitary method, you will apply it throughout the chemistry. In mole concept, in limiting reagent, everywhere, right, you will apply unitary method, right? So don't think that, ma'am, in this question, okay, ma'am, we can ignore this question, some other question, I'll gain the marks. No. Unitary method is applied everywhere. It is applied everywhere, right? So here you have this much of, this is giving you this much of copper. 1 gram will give you this by this, and 100 will give you multiplied by 100, right? Okay. So answer will be this. You will have 80 gram of copper here. You don't need to calculate the percentage. Just remember that 80 gram of copper is there, right? Same thing I'll do here. Same thing I'll do here. This is copper oxide. This is copper. This much of copper oxide is giving you this much of copper. So 1 gram will give you 1.84 divided by, what is this? 2.30. So this is 2.30. 100 gram will give you, this is multiplied by 100. And this is how you have your answer. That is 1.84 divided by 2.3 multiplied by 100. And you will again get 80 gram of copper. that is the same amount of copper you are getting in both the experiments, right? If you fix the copper oxide, that means what exactly we are doing? I am saying that if I have 10 liters of water, I will always have this much molecules. I will have only this much of H2 mass, right? We know that 1 liter will always have the same mass of oxygen, right? That's why we are saying that this 100 gram we are fixing. That I want to see if in 100 grams we are getting the same amount of copper, right? Ma'am, why we are not seeing the oxygen here? Because they have given us about copper and CO2. The information is given about copper and CO2, CuO, right? So if the information about copper is given, so I'll see how much amount of copper it is producing, right? If let's say the information about oxygen is given to you, so I'll see how much amount of oxygen it is given. Is the oxygen same here? Then I'll talk about that thing, right? Okay. Yes, everybody, clear? Very good, very good. Is that clear to everybody? Law of definite proportion, right? I think with the help of questions, it will be more clear to you. Because when you do the questions, things get more into your head. Just by reading out the definitions of these laws will not work, right? Okay, so now we have law of multiple proportion, right? Multiple proportion, guys. Law of multiple proportion. Now, in a simple language, I'll tell you what they mean. So we are saying that you have hydrogen and oxygen. If you're mixing this in the ratio of H2, where you have 2 atoms of hydrogen, 1 atom of oxygen, you will get a different compound. If you're mixing in this ratio, 2 atoms of hydrogen, 2 atoms of oxygen, you will get a different compound. This is water, this is peroxide. Their chemical properties, their physical properties, their structure, everything is different, right? Similarly, you have carbon and oxygen. Carbon and oxygen, if you have, you can also get carbon monoxide, you can also get carbon dioxide. So two atoms, when they are combined in different ratios, in multiple proportions, you will get different products. You will get different compound, right? So what do you mean by that? When two elements combine in two or more compounds, right, to form two or more compounds, then the mass of one of the element that command, now this will be little, you have to see this, okay? So let's say I am saying you have two things here. One is water is making, one is H2O, other is H2O. With the help of examples, you will be able to understand it more. The masses of one of the element, that means that combines with the fixed mass of other. So that means I have to fix one mass. I have hydrogen, I have oxygen, I have hydrogen, I have oxygen. You have to fix one of the mass of atom, right? Which mass you want to fix? Can you see one thing here? This has 2 hydrogen, this also has 2 hydrogen. So can I fix this here? So what I'll do, I'll fix hydrogen here. Fix hydrogen here, right? So once you fix hydrogen here, you need to calculate the ratios. So they are saying that the masses of one of the element that combines with fixed mass of other. That means this is a fixed mass of other. This is one of the element. That means the masses of one of the element out of these hydrogen, oxygen, one element that does not have a fixed mass. Oxygen does not have a fixed mass. So what I'll say, the ratio bears a simple whole number ratio. Mass, here the mass is, oxygen is having what mass? 16. Here oxygen is having what mass? 32, because 16 into 2, 32. The ratio of these two is going to be 1:2. Isn't it the simple whole number ratio? Isn't it the simple whole number ratio? Isn't it the simple whole number ratio, students? Right? Okay. Everybody, is that clear? Is that clear, everybody? Yes, students. Yes, students. Is that clear? Right? Mass, this is law of multiple proportion. What you have to, why I'm teaching you with this, the help of example, so that you can see that one mass is fixed, right? One of the atoms has fixed mass, and the ratio of other, where the mass is not fixed, that is going to be in the simple whole number ratio, right? Now, other examples are like you have N2O, you have NO2, you have N2O3. Which mass I can fix here? Which mass I can fix here? I'll tell you that how to fix this thing, right? Okay, so that's a very, very interesting thing, right? It's a very, very interesting thing here, right? Especially for nitrogen, right? So what it'll do, we have N2, we have NO2, we have N2O3, right? Which mass is easy to fix? I think nitrogen is easy to fix. I can multiply it by 2, and can I get here N2O4, right? Because I need to fix. So what I am fixing here, fix mass of, it's not like, ma'am, always who will tell me which mass to fix. It's your choice, right? I am thinking that, okay, nitrogen is easy to fix, right? Because oxygen is variating a lot, right? So that's why I'm fixing the mass of nitrogen here, right? Fixed mass of nitrogen, right? This is the mass of nitrogen. This is the mass of oxygen, right? So if you see this here, the mass of nitrogen is 28. The mass of nitrogen is 28. The mass of nitrogen is 28, right? Mass of one nitrogen is 14. 14 into 2, 28. Mass of oxygen is what? Mass of oxygen is 16. Mass of, I'll just write it here. Mass of oxygen is, so I'll write it with white pen. Mass of oxygen is 16. Mass of oxygen, here you have 4 oxygens. Because corresponding to 2 nitrogens, you have 4 oxygens. So that means 4 into 16, right? Okay. So that is going to 24, 4 to 64, right? So answer is going to be 64. Mass of 3 oxygen corresponding to, you have 3, right? Okay. So that is going to be your mass of 3 oxygens, right? Now, once you have this, you need to tell me the ratio of these 3 things, right? That should be in simple whole number ratio, 16, ratio 64, ratio 48. That is going to be 1 ratio 4 ratio, yes, ratio 3, right? So answer is going to be what? That is the simple whole number ratio. Simple whole number ratio. That is another example of this, right? Okay. Okay, students. Clear, everybody? Any doubt here? Any doubt here? 1 ratio 4 ratio 3, that is going to be the correct answer here. Okay. So this is the law of multiple proportion, that no matter how many compounds you have of two elements, two same elements, right, that are in different proportion, if you fix the mass of one thing, the other will have the simple whole number ratio, right? Okay. Yes, everybody, this is the snip from your NCERT. You can see this here. That is given to be oxygen, hydrogen. These examples are there. The same definition is there, right? Okay. More than your NCERT only I am teaching you, right? Why I am giving you side by side the snips of NCERT, so that you can go through that also, right? Now, question is, on analysis, it was found that black oxide of copper and red oxide of copper contain 80 and 89% of copper respectively. That means 2 compounds are given to us, right? Different composition is there. Show that this data is in accordance with law of multiple proportions, right? 2 oxides are given, black oxide of copper, and then there is red oxide of copper, right? On analyzing, it was found that the black oxide of copper contains 18 into copper respectively. Black oxide of copper that contains 80% of copper, 80% of copper, and you have red oxide of copper that contains 89% of copper, right? Respectively. Now what you have to do, you have to fix one thing, right? Either copper or oxygen you have to fix, right? Then you have to see is the other is in the simple whole number ratio or not. This is what you have to do, right? Okay. So if copper is 20, copper is 80, then this will be 20% of oxygen, right? Okay. And this is going to be what? This is going to be 11% of oxygen here, right? Now you need to firstly either you can find out the ratio, you can do it that way, or you can just extend this to percentage, right? And then you can find it, totally your choice. But we need to fix one thing that you should remember, right? One thing, copper or oxygen, you have to fix it, right? Mass should be fixed. Black oxide of copper is CO, red oxide of copper is Cu2O, right? Now if you see this here, percentage of copper is 80. This is percentage of copper in this is 20%. Wait a minute. No. I think this should be percentage of not this. Percentage of copper in this. This is wrong. Right? Let me just correct it here. This is not percentage of copper. This is the percentage of oxygen that I have taught you in CO, right? Percentage of oxygen in CO 20%, that I have written all of this here, right? Now that is, this all is what is given to you. This all is what is given to you, given in the question, right? This is given in the question, that you don't have to worry about, right? Now let us see this. What I am asking you to fix one thing, right? So this is CO, this is Cu2O. What can you see that which one can we fix, right? So can we fix oxygen here, right? Then we can find out is the amount of copper that we have is the same or not. So let's do this. 20 gram of oxygen contain 80 gram of metal, 80 gram of that means 20, if you have like oxygen is 20 gram, 80 gram of copper is there, right? 8 gram of oxygen combined with how much amount? We are fixing it here, right? Now 11 gram of oxygen combines with 89, that is from this side, right? Not from this side, that is from this side. 11 gram of oxygen is in 89 gram of copper, right? And here also we are fixing it for 8 gram, and here you have 32, here you have 64. That is the amount of 8 gram of oxygen combines with how much amount, right? Now what you can see here, when you solve the ratio is going to be 1:2. This is a simple whole number ratio, that's why this law is obeyed here. So you need to, what you need to do is you need to fix one thing, right? And that's how you can calculate it for the other, right? Okay. Now you will ask me, ma'am, why we have taken it as 8, right? Ma'am, why not something other? Something else also you can take, right? But just to ease the calculation, they have taken 8. But see, if you are here, you are taking some other gram, then here also you have to take the same thing, right? That means this has to be same, right? This has to be same. That you should do, right? Okay, so here I have taken 8 gram of oxygen combines with how much amount? What is this? 8 divided by 20 multiplied by what we are asking for. So similarly, you can see 20 gram of oxygen, we have 80 gram of metal, right? Okay, so 1 gram of oxygen will have 80 by 20. And how much gram? 8 gram we are asking, then this will be multiplied by 8, right? Okay, rest is your choice. You can take anything here, but just remember that this and this should be same. Whatever you are taking, that should be same. Only then we can see the verification if it is there or not, right? And this that you are getting here, right, the amount that you are getting here, that is going to be in the simple whole number ratio, then it is correct, right? Okay, sure. Now, let's do the next one. It is based on the same thing, right? Hydrogen and oxygen are known to form two compounds. Two compounds they are forming. The hydrogen content in one of these is this much, while in other it is this much. Okay. So that this data illustrates. So what exactly they are asking you? They are saying that hydrogen is known to exist in two forms. The hydrogen content in one of these is hydrogen in that compound is 5.93%, and here it is hydrogen in other compound is going to be 11.2%. Say two compounds we have, one is H2O, other is H2O. Which compound has more ratio of hydrogen? That will be your this one, right? Which has more ratio. So if you see here, you have, you just need to calculate by mass also. This will be 2 ratio, this will be 2 ratio 16, that is 1 ratio 8. This will be 2 ratio 16, that will be not 2 ratio 16, that will be 2 ratio 32, that will be 1 ratio 16, right? So here the ratio is 1 ratio 16. That means in the 8 parts of oxygen, you have 1 part of hydrogen. In this 16 part of oxygen, you will have 1 part of hydrogen. So which one has less? It's like you have 8 balls here, 8 balls here, 1, 2, 3, 4, 5, 6, 7, 8. And out of that, only 1 ball is of hydrogen, right? And in this case, you have 16, out of which only 1 ball is of hydrogen. That means this has more percentage of hydrogen, right? Okay, this has more percentage of hydrogen, isn't it? Right, everybody? So that means this is going to be more percentage, means hydrogen content in one of these is this, and while in the other is this 11.2. So this is hydrogen is H2O, this is hydrogen in H2O2. Firstly, that thing should be clear in your head. Once this thing is clear to you, then things are going to be easy for you, right? Now you just need to tell the data here, right? Again, for the data, if I am saying that this is in the ratio, this is in what ratio? This is in what ratio? Here I am fixing the hydrogen content here, right? Okay, you can fix anything here, and you need to find that how much amount of oxygen you are getting from there, right? Okay, but here you need to also know that this much amount is giving you how much amount of oxygen, right? Okay, for that what we can know that this is in the ratio, how much in the ratio? This is in the ratio 1 ratio 16. This is in the ratio, this is in the ratio 1 ratio 8, right? So what will be our like way of proceeding through this? We'll fix the amount of hydrogen, right? Like some amount, 100 gram, 10 gram, anything you can take. How much amount of oxygen it is giving to us by the unitary method. But for that, you should know that if this percentage of hydrogen is having how much amount of oxygen, right? So the rest will be the percentage of oxygen, right? You subtract it from 100, that will be the percentage of oxygen. You subtract it from 100, that will be the percentage of oxygen. So it will be, you can just write it down here. It is same as what we did before, okay? It is same as what we did before. Wait a minute. Percentage of oxygen, students, percentage, or you can say oxygen in H2O2 is going to be, oxygen in H2O2 is going to be 100 minus 5.93. This is going to be oxygen in H2O is going to be 100 minus 11.2. And from that, you will apply the unitary method, right? Okay. So once you know the oxygen content here, you know everything. Till here, we have discussed the content of oxygen, you have the content of hydrogen, you have. Now, same thing what we did before. Fix the amount of hydrogen. See, are you getting the amount of oxygen in simple whole number ratio or not, right? So, in the first compound, the number of parts by oxygen combined, 1 part by mass of hydrogen. That means here simple thing is, wait a minute, this you don't have to do this way, right? It's not needed. This is another way of doing this. Another way is that you can take the ratio of both the things, that is the mass of oxygen by hydrogen. This is also oxygen by hydrogen. This part and this part, then you take the ratio of both of them. You are going to have it in simple whole number ratio. Or you can also solve it this way, that you can fix that. I'll just tell you how you can do it. You can say that how much amount of hydrogen, I'm fixing the amount of hydrogen, right? So 5.93 gram of hydrogen is going to give you 94.07, right? And you can say then 1 gram will give you how much? 1 gram will give you 94 by 5.93, right? Now I am fixing for one thing, right? Let's say anything you can take, I am fixing it for 10 grams, okay? Say I am taking a random value. For 10 grams, it is 10. So similarly, in the second case, for 10 gram of hydrogen, it is going to be the amount of percentage of this divided by the amount that we had before, 11.2 multiplied by 10. Now you take the ratio, you are going to have the same thing here, right? So I'm just telling you here, this is the shortcut method. This is the shortcut. This is the shortcut, right? This is the long cut. This is unitary method. You firstly apply, you fix any ratio. Because see, why they are not taking here? Why shortcut can be applied? Because eventually the mass of hydrogen will cancel out only. All you have to do is oxygen by this ratio. Here also we are doing the same thing. Oxygen by this, oxygen by hydrogen. Taking the ratio, we are getting the same thing. So this is the shortcut, that you have two things. This shortcut we could also have applied it here. Here, how we would have done it? Here we could have also applied it like this. This is the oxygen by copper. Oxygen is 80, copper is 20, and here oxygen is 89, copper is 11. You take the ratio will be 1:2. Okay, so that is the shortcut. Okay, so that is the shortcut that you can apply. But to understand the shortcut, you should understand how we can convert the shortcut, like how to generate the shortcut. If by chance you forget about the shortcut, you should know what is the long method here, right? Okay, students, right? That's excellent, Komakula. Future IITN. Very good, excellent. Good to know that. Okay, is it compulsory to prove it? Abhijit, it's not like these kind of questions will be asked to you. See, when I give you the definitions, okay, these kind of questions can be there in board examinations. But if I talk about the point of JEE, just understand this concept, because this will not be directly asked to you, but maybe in some question, especially in JEE Advanced, right, where they mix some random topics and make a new question, right? In some difficult topic, they will put this and they will ask you a question, right? In that, some basic concepts of chemistry plays a very important role, right? Okay, so that's why I am teaching you this from the questions, because just by definitions, things will not be clear to you. You have to go through the questions, only then you will understand what is happening here, right? Okay, yes, everybody. Now let's do the next one, that is Gay-Lussac's law of gaseous volume, right? That is our fourth law. So this is when gases combine or are produced in a chemical reaction, right? They do so in simple ratio by volume, provided that all gases are at same temperature and pressure. Simple is, if the temperature and pressure is same, if I take the ratio of hydrogen, ratio oxygen, then the answer is ratio, this is also in vapor form. I am assuming that water is in the vapor form. Ratio 1, then that is going to be 2:1:2. So that is the simple whole number ratio, right? Okay, so ratio by volume of this and this is this, which is a simple whole number ratio. This is what they want to tell you. This may seem very easy to you. What's the big deal in this, right? So at that point, thinking about this thing, that if the pressure and temperature are constant, if you have not changed the pressure and temperature here, the gases will combine in the form in which they are in the simple whole number ratio, right? Okay, so you can see another example here. This is 1:3:2. that is also a simple whole number ratio, right? So you can see this here, 1 volume of nitrogen combined with 3 volumes of hydrogen, right? Now some students might ask, ma'am, is this volume? Ma'am, is this, they are telling us about the volume? That we will learn in stoichiometry, right? First we will understand mole concept, then we will understand stoichiometry. That will tell you why we are saying that this is the volume, right? Till now just understand that this is defining the volume, right? 1:3:2, that is giving you a simple whole number ratio, right? Okay, so everybody, now let us just go through this. Everybody 450 in me thinking they could draw. I'm a big fan. Do you like the do? Yeah. Okay. Now let us see this here. When 10 milliliters of propane is combusted completely, right? So let's see this question. Okay. 10 milliliter of propane is combusted completely. Volume of CO2 obtained is in similar condition is. So you have propane, that is C3H. So it is propane. The formula of propane is CnH2n plus 2. This you will learn in hydrocarbons. Okay. So N is the number of carbon atom. It is 3. Hydrogen is 3 into 2. 2 plus this 8. Right. Now, ma'am, is it like very important to learn this? Don't worry, you don't have to learn this. In organic chemistry, this will be the easiest thing you know. Right. So C3H8 is going to be the formula of propane. Is combusted, whenever there is combustion, you have the answer as carbon dioxide and you have water. So firstly, you need to understand that here what you have is volume of CO2 obtained in the similar condition. This is 10 milliliter. This is 10 milliliter. You firstly have to see that if what is the what is the balancing of this reaction. This is 3, so this will also be 3, right? 3 carbons, 3 carbons. Oxygen is how much? This is 8, so this has to be 4. 4 into 2, 4 into 2, 8. Now oxygen is 4, here oxygen is 6, right? 6 plus 4, 10. That means this will be multiplied by 5. So now can I say it is balanced? Now is it balanced, students? Right? Now is it balanced? Hit and trial you have to apply in balancing, right? So you have 10 here. This will be multiplied by 3 because this is getting 3 times of that. So that will be 30 milliliter, right? So answer is going to be 30 milliliter is the correct answer here, right? All you have to do is apply Gay-Lussac's law that the same amount, the ratios, this 1:3 is the ratio of the volume only. So if this is 10, this will be multiplied by 3, that will be 30, right? So answer is going to be C is the correct answer here. Next is fifth law, that is Avogadro's law, right? Avogadro's law, very interesting, right? That he said that under similar conditions, that means if you have the same conditions of temperature and pressure in Gay-Lussac's and Avogadro's, they are talking about same temperature and pressure. Okay. So Avogadro states that if you have same temperature and pressure, equal volume of gases contain equal number of molecules. What do you mean by that? Okay, let's see this. You have a tub where you have H2. Again, you have not a tub, a cylinder where you have Cl2. Okay. Now, I am saying the temperature and the pressure is same in both the cylinders, right? So in this cylinder, I think the cylinder should be better than this. Okay. So we can draw at least that much better. I am in, like, I don't have that much bad drawing that I can't even draw a cylinder, right? So H2 and Cl2 you have here, both are gases and they both are talking about gases only. Equal volume of gases contain equal number of molecules. If I say that this is 10 milliliter, this is also 10 milliliter. If I say this is 10 milliliter and this is 10 milliliter, then if I say this contains 100 molecules, then this will also contain 100 molecules. Okay, everybody? Okay. Now, I'm not getting into moles because I have not till taught you mole concept. So that's why I'm just talking about molecules. Okay. But understand one thing, if molecules are same, moles will also be same. How they will be same, that we will talk about in mole concept. Right? If I say that this is 10 milliliter, this is 20 milliliter. Volume is doubled. That means if I say here you have, let's say, n molecules, n number of molecules, this will have 2n molecules. This will have 2n molecules. Understood, everybody? Now, what we discussed from here is that if this is 10, if the volume is doubled, molecules will be doubled, moles will be doubled. Right? If volume is half, molecules will be half. That is called Avogadro's law. Okay? Under similar condition, equal volume of gases contain equal number of molecules. Right? Okay? Right? Okay, students? So this is your Avogadro's law, right? You can read it out from your NCERT. This is everything that I have taught you. Avogadro's, that equal volume of all gases at the same temperature pressure should contain equal number of molecules, right? Distinguishing between atoms and molecules. This we will discuss. Don't worry about this, right? This we will discuss, right? Okay. Now let's talk about some questions here, right? Okay. Why I'm not asking you to read out it full? Because once we have gone through Avogadro's number, mole concept, that thing will be more clear to you, right? Now let's understand this. How much mass of silver nitrate will react with 5.85 gram of sodium? Now the question that is given to you is, how much mass of silver nitrate, you have a mass of silver Ag, nitrate NO3, will react with 5.8 gram of sodium chloride. This much gram of sodium chloride NaCl is given to you to produce this much of simple law of conservation. Very simple question, students. Everybody, now because we have this question here, so I want you guys to answer this, right? This is silver nitrate, but after this, instead of questions, first I'll teach you last law, right? That is not mentioned in like NCERT. So we'll discuss about that. AgNO3 reacted with NaCl, right, to produce silver chloride, AgCl, plus sodium nitrite, that is NaNO3. Right? Now, if you see this here, this is given to be 5.85. This is given to be 14.35. This is given to be 8.5. And this is, let's say, x. So we know that it will be x plus this is equals to this plus this, and x will be equals to 14.35 plus 8.5 minus 5.85, and you will get your answer of how much AgNO3 you will have here. Right? Okay. Who will answer? Who will answer this in the chat box? What is the amount of AgNO3, everybody? Who will answer this in the chat box? Yes, students, who will answer this in the chat box? Okay. PDF of the lecture will be available in the comment section or description. Rishwant, it will be available in both description box as well and in the comment section as well. Right? Okay. Yes. Very good. Very good. Ma'am, how to get AIR 1? I'm in 9th class. How should I practice? Abhijit, you are in 9th class. At this point, just attend the lectures. Okay? Just attend the lectures that we have here on YouTube. That will be enough for you. Right? If you do this here. Right? Okay? Focus on concept clarity. Focus on doing the topics in detail. And focus on as much as depth you can get into. Right? Okay? Yes. Okay, so we have our answer. That is C is the correct answer. Now, let's talk about other 3-4 questions. Then I'll talk about one more law. And let me see who can guess that name of that law. That is not there in NCERT. Let me see who will guess that. Among the following pairs of compound, the one that illustrates the law of multiple proportion. Law of multiple proportion is illustrated by which? Multiple proportion. Everybody, easily you can answer this. Multiple proportion means atoms, elements should be same, but proportion has to be different. That means the ratio, the proportion in which they are combining has to be different here. Right? Let me see who is going to answer that. Atoms are same, proportions are different. Right? Very good. The answer is C. Atoms are same, proportions are different. So answer is going to be C is the correct answer. Very good, Abhijit, Vignesh, Komakula. Very good. Very good. So next is, which of the following pair shows multiple proportions? Right? Very good, Tharun, very good. So, which of the following pair shows law of multiple proportion? Law of multiple proportion, right? Again, same kind of question is there. Who's not able to answer the first one? Now you have the option, like you can answer this now. Okay, so let me see how many of you, how much percentage of you are able to answer this, right? Okay, let me see how much percentage of you are able to answer this. Very good. Very good. Very good. A. Very good. A is the correct answer. CO2. A becomes your correct answer. Last one is CO2 and C2O3 follows which of the following? Law of definite proportion, law of multiple proportion, law of conservation of mass, or none? CO2 and C3O3. C2O3 is following law of definite proportion, law of multiple proportion, law of conservation of mass, or which of the following, right? Okay, let me see that. Let me just end the poll and let me see how many likes till now you have provided. I think it should be very good. I want you guys, all the students who are watching this on recorded version, better do hit the like button, because this is how YouTube algorithm works, right? We want to spread this knowledge to other students also who are in need of this. And this also is an appreciation boost for your teachers as well, right? Because so much hard work we do for all of you, right? Okay. Okay, very good. So I'll just see. Okay. I'm going to conduct a poll here for this. Let me see how much percentage of you are able to answer this. Let me see that. I want 100% correct answer here. Very good. Very good. Very good. Array? Very good. 80%, 75%. Few students not able to answer it. It's okay. It's okay. At least you are trying, right? So answer is law of multiple proportion. That is B is the correct answer here, right? B is the correct answer here. Okay, yes. Now let us see the next one. That is, okay, for this now, this is our surprising law that I was talking about. Law of reciprocal proportion. This we have not talked about till now, right? Now we will talk about law of reciprocal. You have understood law of constant, law of multiple, law of definite. But ma'am, what is law of reciprocal proportion, right? That becomes very, very important for you. So I'll teach you that law where. Do I have a blank slide anywhere? Do I have a blank slide anywhere? We don't have. Oh, it's okay. It's okay. It's okay. Don't worry. We'll use this, right? That is law of reciprocal. Law of reciprocal proportion. Right? Now, if you just directly see the statement, you will get confused, right? If you directly see the statement, you'll be like, ma'am, what is this law, ma'am? I'm not able to understand this, right? So I'll give you one example, and from that example, we will understand, right? So the example is that what we have two elements. One is carbon, other is sulfur. Two elements I have, one is carbon, other is sulfur, right? Now, we are saying that there is some third element, right, that is combining with both of them. right? So let's say it is oxygen, so it is CO2 and this is called CS2. Okay, that is combining like this. Carbon with sulfur is CS2, carbon with oxygen is CO2. Arey, nahi. This is wrong, right? I made oxygen constant, so I have to take oxygen only here, right? So I'll take SO2 here. Okay, I'll take SO2 here. I'll take SO2 here. If you want to take carbon, okay, I'll take SO2 here, right? Okay, just see this, right? What we are going to do. You have what we have, right? Chalo, firstly, let's do this. You have CO2, you have SO2. Two elements, you have carbon and sulfur. You are combining both the elements with a element that is same for both of them, oxygen and oxygen, right? Now, what we are saying that if we talk about when we fix this thing here, when we fix this and this is fixed. This is fixed, okay? Two elements are combining with the fixed mass of third element. Is this statement clear to everyone? Two elements are combining with the fixed mass of the third element. Can I write it here? Two elements. I'll just side by side, I'm writing the definition also. Two elements combine. By teaching example only, I'm going to write the definition. Two elements combine with fixed mass of third element. And here we are saying that in this fixed mass, right, if you see the ratio of this and this, the ratio of the remaining, the ratio of this and sulfur here, carbon ratio sulfur is going to be what? Carbon is 6, sulfur is what? Sulfur is 32, okay? Sulfur mass is 32. Right, the mass of the, carbon is not 6, the atomic number is 6, it will be 12 ratio 32. Okay, that is going to be the answer for this one, right? Now, other statement is that if you see two elements combine with the fixed mass of third element, then the ratio of those two elements is going to be equal to what? This ratio is going to be equal to what? This ratio is going to be, if these two elements combine together, they will form CS2. They will form CS2, right? And CS2 is what? CS2 is carbon disulfide, right? So this is carbon is 12 and this is sulfur is 32, 32 into 4, 62, 64. Now, even in this ratio, so tell me till here you got it or not? This carbon and this sulfur, when they combine with the fixed mass of oxygen, the ratio of carbon and sulfur is 12 ratio 32. But when they are not combining with the third oxygen, right? They are not combining with the third part. They are combining themselves. They are combining with each other to form a compound. Then the ratio is 12 ratio 64. Now, here also I am fixing this 12 and fixing this 12. Then the ratio is going to be 32 ratio 64, which is going to be a simple whole number ratio, which is going to be a simple whole number ratio. Tell me, student, if that is clear to everybody or not. Tell me, students. Okay, is that clear? Okay. CS2 experiment again, please, ratio of this. We are saying that you have two elements. They are combining with the fixed mass of third element, right? Then the ratio that you have here, what is 12 ratio 32? If you break this ratio, that is going to be, this is 2, 6, this is 1, 6, this is 3, and this is 4. So it is going to be 3:4, right? And here it is going to be 1:4, right? So this is going to be 1:4. This is going 1:4, no? No. It's not 1:4. 16. 1:6. No? Wait a minute, it's not going to be a constant ratio here, right? If I just tell you that, wait a minute. So it's, we have to, wait a minute, that is 6, 1, this is 3, 2, this is again 6:32, so that is 3, this is 1, 6, right? 3:16 it is going to be, isn't it? 3:16, right? 2, 6, 2, 1, 2, 3, 32, this is then 3, this is 1, 6, 3:16, okay? So either you can use it like this, 3:16. Okay, so now he is saying that when you have these two elements, they are with the fixed ratio of the third element, right? Fixed mass of the third element, they are in some ratio. And when they combine together also, they are making a compound, that is carbon disulfide. It's a compound that is formed, okay? So when carbon and sulfide combines, because carbon, this is S2 negative, when they combine here, this will be 4 here, and this will cancel, this will be 2, so this is going to be CS2, right? Because carbon has 4 valency, sulfide has 2 valency, right? They will cancel and they will form CS2. So now you have this compound here. They are saying that here, either you can solve it like this, right? You can just say that this ratio that you have, it is a multiple. But I know that most of the students don't understand what is the multiple, ma'am. This is 3:4, this is 3:16, right? So 3:4, this is 4, this is 16. That means this 16 and 4, that is the differentiating point, are the multiple of each other, right? So instead of telling you that this ratio and this ratio is the multiple, what I told you, that you fix this thing, this is 3, cancel it, this is 3, you cancel it. The answer is going to be 1:2, which is the simple whole number ratio. But in reality, the exact definition is when they are combined, right? The mass of, you can say the ratio of two elements in this form is either same or multiple, here it is multiple, okay, or multiple of when they combine with each other, okay. So here I can also give you that what I am telling you here, two elements I am taking, carbon and sulfur, fixed mass of third element I am taking as oxygen, right? So when the ratio, two elements in which they either same or multiple, or when they combine with each other, that means when they are forming CS2, here they are making CO2 and SO2, right? So here the ratio of carbon and sulfur in this case and the ratio of carbon and sulfur in this case are going to be the multiple of each other or the same ratios, right? Okay, yes, everybody got it, right? So that is called law of reciprocal proportion, right? Okay, everyone, understood? Chal. Now let's do two more questions here, right? Two samples of lead oxide were separately reduced to metallic lead by heating in a current of hydrogen, right? Two samples of lead oxide you had, right? PbO you had. The weight of lead from one oxide was half of the weight of other one. This is an example of, see, simple thing is there are two kind of lead oxide, PbO also, there is PbO2 also, right? So they are saying that 2 samples of lead oxide you had, but what happened? The weight of lead from one oxide is half, right, of the other one. That means if you have from here the lead was, let's say it is half and this is 1, right? So this is what that means, the weight of lead is different. That is the only possibility if the ratio are if the ratios if the ratio of Pb and oxygen is different. Because if the ratio of lead and oxygen is different, only in that case, when you reduce the oxygen, the lead that is formed is going to be different, right? So that means here we are talking about which thing? Law of reciprocal constant. What? We are talking about law of multiple proportion, because the ratios are going to be different in this case, right? Okay, everyone. Next is chemical equations are balanced based on which thing? Anybody in the chat box? Chemical equations are balanced based on which thing? That is law of reciprocal. Reciprocal, we have not talked about anything about balancing. Balancing we were talking about in case of conservation of energy. When energy should be conserved. Why? Because energy is conserved. That is the reason the atoms are conserved, right? So that's why we need to balance. So it is based on law of conservation of energy, right? Sorry, conservation of energy. I am saying conservation of mass. I'm so sorry. Yes, conservation of mass. Because here we are talking about conservation of mass, not conservation of energy. My bad. Right answer will be B, that is law of conservation of mass. Right? Now, next is who proposed the equal volumes of all gases at the same temperature and given pressure should contain equal number of molecules. Now, equal number of molecules is proposed by which of the following? Equal volume will contain equal volume, will contain equal number of molecules. If the volume is doubled, molecules will be doubled. The scientist fifth law we studied. Very good. The answer is C, that is Avogadro's law, right? Next is, what did Joseph Proust state regarding law of definite proportion? A given mixture always contain absolutely same proportion of element by weight. A given compound always contains same proportion of moles by weight. A given compound always contain absolutely same proportion of elements by volume. Same proportion of element by weight. First thing is, he was not talking about any mixture. He was talking about compound, right? Mixture is a different thing, right? Mixture is like you have water, you add lemon into it, you add salt into it, sugar, that is a mixture. A compound is when chemically you have so many atoms that are chemically bound to each other, right? So he was talking about compound. Always contain absolutely same proportion, same, till here everything is same. Of moles by weight, no. Of elements by volume, no. Of elements by weight, yes. So answer will be D is the correct answer. He said that by weight it has to be same, right? He never talked about volume or anything. The statement was by weight, right? Now students, take the screenshot. These are 2 questions that I am giving you for your homework. That is law of definite. I want every single student here to do their homework, right? If you're not doing the homework, you are ruining my energy and my devotion to this channel, right? To you guys, right? You're actually disrespecting me if you're not doing your homework, right? And you're ruining your time as well, because you're not passionate enough to do your homework, right? And once you don't have that habit, forget about practice and DPPs, right? Okay, DPPs I'll only start providing when you start doing the homework, right? Once I see 30-40 comments in the comment section, even the students who watch this for recorded, then I'll see that, okay, these students are, very disciplined. If I see that discipline within you, surely I'll start giving you the DPPs as well, right? But for that, I need to see your efforts as well, right? So law of definite composition is also known as law of multiple proportion, Avogadro's law of constant or conservation, right? This is the first question. Take the screenshot here. Second is 1 gram of oxide A combines with this much of A. 4 gram of another oxide A combines with this much of A. The The date indicates law of the data. The data indicates law of reciprocal, constant, multiple, or definite proportion, right? So these are the two questions. First question is this one. This I hope so everyone will be able to do this. Second question, let me see how many of you are able to. You do it right, do it wrong, it's okay. But if you try, this is what matters to me, right? So take the screenshot and do this question as well. I'm waiting for your answers in the comment section, right? And to all the students here, right, guys, you can see you were asking me in the chat box about, ma'am, I want to be AIR1, right, ma'am? This is my dream, right? So you can see our shining stars on the board, right? This is our Vedantu shining star of JEE Mains and Advanced results, right? And you can see AR15, Daksh, who is Karnataka State rank 1, right? So how they are able to do this? With the perfect guidance, right? And for that guidance, at this point, an opportunity is knocking on your door. That is IVSAT scholarship program. For that, you just have to register yourself to this IVSAT scholarship program, right? And you can avail up to 90% scholarship here. And for all the droppers and repeaters, if you're watching this, then students, we are also providing guaranteed rank improvement, or otherwise 100% fees refund will be there, right? And this is our RIG batch, RIG, rank improvement guaranteed. And students, for all my 9th, 10th, 11th aspirants, especially this is for you. All the students who are watching, who are in 9th class, 10th class, 11th class, right? And even 12th, I have already told you about your IVSAT scholarship program, right? And droppers as well. But for the aspirants, right, who are clueless about the journey at this point, right? Guys, you need a proper guidance, you need a proper counseling, right? And for that, you can visit your nearby Vedantu center. You can see that over here, Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Uttar Pradesh. All these states, cities here, you can see our Vedantu centers are located. What I would advise you, go and visit, right? Nobody is charging you to visit. Nobody is charging you for any counseling or guidance, right? You just have to tell that I am a student of Vedantu JEE English, shares the Diksha Ma'am and Namrata Ma'am. That's it. This is what you have to tell. And the guidance, the counseling will be provided to you by the teachers, by the team, right? And you can also contact, if you're still clueless that should I go, should I not go, you can just call here, right? Call on this, right? This is the number of JP Nagar Bengaluru Center, right? You can ask that counselor to give you the number of your nearby center that you can locate. Like you can just type it in the Google Vedantu Center nearby, or you can also see this over here in this list, right? That will be provided in the PDF version as well, right? Just talk to the counselor, right? That what should be my guiding path here, right? I want to have this target. This is my target, right? Now, what will happen in this case? If you have the correct guidance, you have the correct mentorship, right? In that case, your potential will be 100% used, right? So what we have seen in students after like dropping 1 or 2 years, then they realize that, okay, I had this much potential. But at that point, there is no use of that because you don't have that many attempts, right? In JEE, you have restriction regarding attempts, right? So if you're, let's say you are giving your board examination 2027, 28, 29, that will be your last year of giving the JEE Mains, right? 20 till 29 only you can give, 27, 28, 29. That's it. And 27, even if you give the JEE Mains or not, that will be included in that one. JEE Advanced, you can only give 2 attempts, right? That is 27 and 28, that's it. So every single year is important for you. Your board year is very important for you. For that, you actually, if there was no restriction about the attempt, then also you could have thought that, okay, first I'll focus on board. But for JEE Mains and Advanced, you can't have that strategy. For that, guidance should be very clear to you. And for that, you can just click on the description box. You can tell me that, ma'am, I need this guidance. You can also write it in the comment section that I am living in this state, this city, which is the nearest Vedantu center near me, right? The link is in the description. Click on the link. Just register yourself for the offline meetup so that you can also meet the counselors, the teachers there, right? And students, this is our official Telegram channel. Just scan this and you'll be land up to the page of Telegram, right? here what will happen, you will have the proper knowledge that when ma'am is going live, when the sir is going live, when some notification regarding JEE or any other exam of engineering, the state exam also we focus on. So any other exam also, any new notification is there, right, that will be on this channel, right? Okay, so that's it, students. Now I want you guys to comment down your homework in the comment section, and I'll see that how many of you actually do your homework, right? Okay, future item, you write your comment over here in this video because I have no idea in which other video you have commented. So write it down in this video, right? Okay, yes. Okay, then bye bye, take care, see you all in the next class, right? Bye bye, take care.